Now, I told you that the normal thing to have happen was that the two equations give us lines that intersect at one point. Let's look and see what happens when we try to solve the system y equals 1/2 x minus 2 and x minus 2y equals 0. Again, I'm going to label these equations A and B, and I'm going to graph each equation. The first equation is in slope-intercept form, so that's easy to graph. We'll get y-intercept -2. Slope is 1/2. That means I go over 2, up 1. As for B, this is not in slope-intercept form, so I'm going to try finding the intercepts. Alright, so let's let x equals 0. I'll get 0 minus 2y equals 0. Minus 2y equals 0, divide both sides by -2. We get y equals 0. That tells us that the point 0, 0 is on the line. But that's both of the intercepts, isn't it? How are we going to get another point? Well, we have a lot of choices. We could rewrite this in slope-intercept form, or we could just, instead of picking one of the variables equals 0, we can try a different number. Maybe we can try, let y equal 1. Let's see, what will we get? X minus 2 times 1 equals 0. X minus 2 equals 0. Add 2 to both sides and we get x equals 2. So that tells us the point 2, 1 is on our line. 2, 1. Draw in this line, and what do we see? We see that these lines don't cross, certainly. But more than that, we notice that these lines are parallel. They have the same slope, right? Over 2, up 1. Over 2, up 1. These lines are parallel, which just means that no point is on both lines. They never cross. What does that tell us about the system? Well, in order to be a solution to the system, it has to be a solution to both equations. It has to be a point on both lines. There are no points like that. Therefore, this system has no solution. If we're asked to solve this system, we answer no solution. It can't be done. Such a point doesn't exist. Now remember, I told you that when the lines cross at just one point, the system is called consistent independent. In this situation where the lines are parallel, where we have no solution, the system is called inconsistent. And this is just the usual English use of the word inconsistent. Can't both be true at the same time.